is going on, guys? Welcome back to a new video. Today we're going to be talking about sorting algorithms. Now we're going to start off with the bubble sort, of course. Now, before I do get into this video, I want to say if you're looking for a job or internship, check out the first link in the description. I think you'll really enjoy the guide I made. It's completely for free, so check it out. With that being said, let's get right into the video. So, sorting algorithms. Now, a brief overview of the sorting algorithms that we'll have. Binary search was efficient when given a pre-sorted data. But what are the most efficient ways to actually sort the data sets? Now, here are many different sorting algorithms, but you are going to focus on four of the most common ones: bubble sort, merge sort, quick sort, and radix sort. Each has its pros and cons when it comes to their efficiency, as you can see in the table. So the best case is O to the n. Merge sort has O to the log n, or n log n, which is slower than bubble sort. Quick sort is n log n. Worst case is n squared, n log n squared. Average case is n squared, n log n, n to the 1, or sorry, O to the 1, n, and then log n. Pretty good, right? So it just depends on which one you want, if it's the best case, worst case, or average case. Average case, I think, I want to say this one, the merge sort is probably the best one, but we'll get more into that in a bit. So, to start off, if this thing will load, we have bubble sort. Okay. Now, what is bubble sort? Okay. Bubble sort is an introductory sorting algorithm that iterates through the list and compares pairings of adjacent elements according to the sorting criteria. The algorithm swaps elements to shift elements toward the beginning or end of the list. By default, a list is sorted for any element E in position 1 through n. So, for example, bubble sort transforms a list like this, 52915, and it makes it 12559. So we implement the algorithm with two loops. The first loop is going to go through how long it is unsorted, and we assume it's an unsorted list to start. Within this loop, another iteration moves through the list. Each pairing and algorithm asks, in the comparison, is the first number greater than the second one? If it is, we swap the elements, or the position of the elements. The larger element is now at a greater index than the smaller element. When the swap is made, we know that the list is still unsorted. The outer loop will run again when the inner loop concludes. This process repeats until the largest element makes its way to the last index of the list. The outer loop will run until no swaps are made within the inner loop. So now, let's go ahead and take a look at this real quick. Okay. So this is what it does. Okay. So we'll just wait for it. Okay, so 3 and 5 are good. 5 needs to be swapped with 4 because it's greater. And then this is good. And 2 is going to get swapped. And then 1 is going to get swapped, right? And then you will go through here. And you just keep going until it's 1, 2, 3, 4, 5, 6, right? You'll just keep sorting through, right? Now, bubble sort, as mentioned, the bubble sort algorithm swaps elements if the element on the left is larger than the element on the right. How does this element swap these elements in practice? Let's say we have two values stored in the following indices, index 1 and index 2. How would we swap these elements? it's tempting to write the code like normally swapping it, but if we do this, we'll lose the original value at index 1. Because if you're assigning index 2 to index 1, now index 2 is equal to index 1, right? So now you're just equaling it together. It's the same value. So let's say index 1 is 1, index 2 is 2, right? Now you're saying that 1 is equal to 2, okay? So you know 1 is equal to 2. Now this is 2. You're saying 2 is equal to 2 now. So you're just equaling both at the same time, which we cannot. We'll lose the original value at index 1, and then the element gets replaced by the value at index 2, so both indices will end up with the value at index 2. Now, programming languages have different ways of avoiding this issue. In some languages, we create a temp value, which holds one element during the swap. So this is basically what it does. So temp is holding 5, and then we'll swap it, and then the 5 goes here, and there you go. So that's how you swap it. So temp basically holds index 1, and then you make index 2 equal to index 1, and then temp becomes index 2, basically. It's pretty easy. And other languages provide the multiple assignment, which removes the needing for the variable, the temp variable. Algorithm analysis. So given a moderately unsorted dataset, bubble sort requires multiple passes through the input before producing a sorted list. Each pass through the list will place the next largest value in its proper place. When performing this, we have n to the minus 1 comparisons for our inner loop. Thus, we must go through the list n times in order to ensure that each item in our list has been placed in the proper order. The n signifies the number of elements in the list. In the worst case, the inner loop does the n minus 1 comparisons for n elements. Therefore, we calculate the algorithm's efficiency, which is going to be n squared, because you have two for loops. So each one has to run n times, so n times n is n squared. The diagram is going to analyze pseudocode implementation of bubble sort to show how we draw this conclusion. I mean, yeah, you have to, again, we have two loops, right? It's a nested for loop, and if you guys go back to the runtime video, a couple videos back, you'll know why this is n squared, right? So that's gonna be the runtime of this algorithm. Bubble sort in the worst case is n squared. So bubble sort review. Bubble sort is an algorithm to sort a list through the repeated swaps of adjacent elements. It has a runtime of O to the n squared. Worst case, right? Now for nearly sorted lists, bubble sort performs relatively few operations since it only performs a swap when the elements are out of order. Bubble sort is a good introductory algorithm which opens the door to learning more complex algorithms. It answers the basic question of how can we algorithmically sort a list and encourages us to ask how can we improve this, right? Now, let's go ahead and take the quiz here. 5 questions, pretty easy, right? Okay, what is the big O runtime of bubble sort? Again, it's O of n squared. Bubble sort orders an input through a series of comparisons and swaps. True. Bubble sort is the most efficient of the comparison during sorting. False. It's not the most efficient. It's a good introduction to algorithmic thinking and sorting, but it is not the most efficient. If no copy is made of the input value, then bubble sort will alter the original array to produce the sorted data set. True. Bubble sort sorts the inputted array by swapping elements within the original array unless a copy is being made at the beginning of the algorithm. An input list that is mostly ordered will require fewer swaps. Well, duh, that makes sense, right? That is mostly unordered. Yeah, that makes sense. So bubble sort will only make a swap if the element is out of order. We got 100. If you guys have any questions regarding bubble sort, please comment them down. I'd be more than happy to help with that. And then also, if you like this, please like the video and subscribe, and I'll see you in the next one. Have a fantastic day.